okay, which actually tried doing something, reading, writing on this .c file, okay. And this is what we asked you to do in the first place, that create a student as a file, operating system file. So you create a data file, and the data file has these entries, name, right, roll number, and CGPA. This is what we had got last time. In fact, I created some few names, including Ramya. If I remember right, in the first class we did this, okay? Created the students as files and used the operating system calls and read write on this. This is what we did in the first class, okay? Now, if you look at database systems are actually built on top of the operating system file. The whole board can be used, this entire, so let me organize myself a little more well, because that will give me the full process of, okay. Right, so this gives little more flexibility for me to actually do the whole thing. So one of the things that we've done is looking at the operating system and doing from the operating system creation of a file. Now on top of the operating system, this is what we are seeing here as, what is the operating system here? The operating system here is Boss Mole Linux. Okay, this is the operating system that I'm using. Okay, on top of this operating system is the files. Okay, on top of this is what the database management system MySQL. Okay, this is where the MySQL code is lying. Okay, on top of it is your PHP or Perl or .c programs. All these are on top of this. Okay, right? So if you blow up this MySQL part alone, okay, how this system looks like. This is the relational database management system. What this system will consist of now is basically a storage manager and a transaction manager. Okay. And on top of it is your SQL, which you have now looked at. Okay, this is what this will have. Okay, this is what I'm going to show you in the system there. I'll show you this. What the storage manager does is, you probably have to adjust the, what the storage manager internally, if you further blow up the storage manager, only the storage manager. Okay, if you blow up the storage manager, so what you will get is, there is files, okay, the operating system files, and on top of it is what you will see the SQL running on top of it. When SQL works with these files here, these files are the same as exactly the operating system files, except that when you have a database, okay, for example, what is the database that we have? Let us say the RC November _ 0809 or whatever it is. This is the database. Okay, this is equivalent to saying that this is basically a directory. Okay, in the operating system, this becomes a directory. Under this, you have a table. Let us say the table is users table. Okay, you have created a users table. This user becomes, under this, again you will get a user table. When you go to this user table, you will get 3 files as far as this database is concerned. This is the schema file. Okay, and then you will get, this is a file that stores the data part of the user. Okay, and then this is the part that is the index part of the. So these are the 3 files, exactly same as the operating system files that are used by the database. Okay, you have a schema file, and you have a data file, and you have an index file. Okay, This index is the most important component of the database management system. Okay. Why is this the most important component of a database management system? Imagine you have a 1,000-page book. Okay. Imagine this thick book, 10,000-page book. Okay. In that book, you want to search for the name Janakiram. Okay. Now, if there is no index to this in this book, what is an index in the book? If you take any book, the index actually tells you which part is where. For example, here is a book here. So if you open the book and you want to actually find which component, the first part is the index, right? To search for anything in this book. If the book doesn't have the index, you need to look through all the pages of this book if there is no index, right? Every book will have an index to start with. And what is this index supposed to give you? The index tells, for example, if you are searching for a name called Janakiram, it will tell you which page this name appeared. That's the index, right? In the absence of that index, you end up searching the whole file. For example, somebody was saying Aadhaar card, right? We are about 120 crore people in India, right? Now we are searching, let us say, for one person, okay, with some name or something in this database, Aadhaar card database, okay? Now, if you end up searching, if there is no index based on name, let us say, you have not indexed this whole database, there is no index. There is no index, but only the raw data file exists, okay? Only data exists. This is what operating systems do. Operating system provides raw data files, okay? And if you put everything into the raw data file, if you're searching for any particular piece of data in that file, you end up going through this entire millions of records. You have to scan through the entire, millions of records, and that is going to be very, very expensive. As the data size starts increasing, as the size becomes bigger and bigger, okay, it becomes very, very expensive for you to be searching through this huge data, huge amounts of data, okay. That's the reason why indexing becomes very, very important. Database, the key thing database does is, given any table, it starts creating this index so that it becomes easy for you to search through this data, okay. Which doesn't, the index is not created by operating system for its regular files, okay, right? I'll come back to this. What is the ways this index is created by database? What are the different techniques for this index, and why it becomes important to generate a proper index so that the operations on the data become very efficient, okay? Before we go further and look at this index, I'll show you with the system, actual system, where these files will be, where the index files will be, and what is one of the interesting assignment that you can do. Please switch to the system. Now I think this is a system that's available with all the colleges, okay, as I think we know that we had actually supplied this, two of the colleges have actually got the installed this thing. So what you need is this virtual box, okay. Take the virtual box. In the virtual box, this VDI file, Bossmool MySQL file, has all the files running. So this basically will give you an interface, something like this, okay. This is to start with. You will get an interface like this. Last class also we gave you this interface. Now I'm going to drill into this and then see this is the interface that you will get. What I'm trying to show you is, for example, in this system, if you actually go and then log in as the this is the logging in into this system. If you look at show the databases here, these are all the directories that you will get. These are all the databases that we have, okay, right? Now, if you're saying that I want to use a particular database, RC November, okay, _18 08. This is a database that I want to use. Okay. Possibly I made a mistake. Instead of RC, I just put 18_18. Okay. Now the database is changed. In this, you can say show tables. These are all the files. For example, there are different tables here. Okay. Now you can see, you can describe the users table here. Yes. Is there a question somewhere? Is a live interaction possible? If there is.
Yes, sir. It is possible, sir. It is possible.
Yeah. Anyone having a question can. If they have a question, let them stop us. Okay. Yeah. You can it now. Kannan.
Yes, sir. I'll mute them, sir.
Okay, so this is the schema of the table here. As you can see, the ID and then the varchar, all this. So this is a primary key for this is the company name is the primary key and user name is the primary key in this table. Okay, which we saw in the relational database model already. Okay, right? Now, if you want to see all the data that is present in this, you're going to now say select from users. This will give you all the, this is the one which will go into this table, get all the data from the table here. Okay. Now you can see this is the data that it got from all the entries in this table. The ID, the company name, and the username and the password. So this whole information as available in this has been printed here. Okay. Now let us say this database has million entries. Okay. Now in this, I want to now check, for example, a particular company based on, okay, let us say select star from users where, okay, username is city. Okay. This is the query that I want to fire now on this. What is this query supposed to do? This query is supposed to go into this users table, and where the user name is city, it should display that data for me. Okay. This is a search query. You're actually doing in a relational database model, you're actually doing the select operation here. Okay. You're selecting some rows which satisfy this condition that the username is basically city here. Okay. Now look at this. This is the entry that actually matches. If you give a wrong entry, then it won't get you the data. It will say that no such entry if this condition is not matching. Okay. Now when you do this search through this table, this is called an equality search. The select statement here is doing an equality search. You can also do a range. For example, you can say, get me all those companies whose ID is greater than 10. Okay, select, for example, I won't do all this. You can write typically you can, this is an equality query. You can also do range query. You can do lots of things with this. Okay. Now the idea is if there are million entries, this has to be faster. This search has to be faster through the table, right? This is where I'm going to show you some relational operators in a minute and show you why this becomes very, very important, why indexing becomes very important. Okay. Remember that I'm doing an equality search here. Okay. Username is city. For example, I can also do a equality search where from user saying that where ID is, let us say 10. I hope there is an ID with 10. Okay. There is 10. This is the USAM Technologies Private Limited. This is the entry that is there with 10. Okay. Right. So this is basically again an equality search. Okay. Now if you say ID greater than 10, then it becomes a for example, you can say get me all the entries where the ID is greater than 20, something like that. That becomes a range query. Right now, I'm interested in looking only at the equality searches for simple reason, the kind of indexing technique that makes immense sense when there is an equality search is what we call as hashing. Okay, so we want to see how the hashing works in a practical databases in terms of hashing, making the equality searches faster for you. Okay, it in fact brings the search cost to an order of constant, order of 1. In fact, if you are able to hash it properly, then the search cost is going to be constant time. Whereas normally if you scan the whole database, it is proportional to the number of items that are there in the database. This search would have been proportional to all the entries in the database. Okay, so we're going to see why this indexing is extremely important. Now, given this, right, so we have actually shown you to get this MySQL system. Actually, we wanted you to git clone. I don't know how many of you have actually succeeded in git cloning this MySQL server database. Okay, now if you look at, for example, the if you have git cloned the MySQL server, then you will get something. Let me see where I'd actually cloned this database. Okay, this is not here. This is in my I've actually cloned it not in the virtual box, but outside the virtual box. Okay, so right, this is now this is actually the, if you had done the git clone on your MySQL server, you will get a directory called this MySQL server here. Okay, if you go there, this can be copied. This MySQL server can be copied. Okay, this is the full server code that you will get. Okay, right. Yeah. See, the idea is to make you now do a little bit more experimentation. If you're not doing this, you will not actually go deeper. Okay, this MySQL full server code can be obtained by you. Whatever I'm doing, you can actually get the full server code. Reading from the book is one aspect. Doing it practically is a completely different aspect. One of the things that we want the students to do is go deeper and start playing with the systems rather than just do the bookish knowledge of seeing something, because that doesn't make them employable. That's the reason why we want them to move into open source, giving the full code and asking them to look at this. Okay, and unless the colleges move into this, I don't think they really understand the deeper concepts. As one of the persons from the industry, top man from the industry, is saying, whatever you are learning now is equivalent to 10th standard. Okay, in the colleges there. Unless you go a little deeper here, you're not an engineer. Unless you're able to play with the systems, you're not an engineer. Okay, this is the best time for you to be actually sitting and then doing a bit of an experiment with the systems. If you're not doing that experiment, okay, that's where I'm sitting and then I'm showing you. This is where you can go. You can get that MySQL full system. Okay, if you go into the MySQL full system, the code of this system, it will look something like this. Okay, you can see here in this there is something called storage here. Okay, there's an SQL and a storage system here. If you go into the storage system here, this is the place where you have different storage systems. Essentially are different from indexing point of view, how they index the given data and how they provide the locking system. That's how these different storage systems are different. Okay, they're actually, this InnoBase is the latest storage system. Okay, the previous storage system that comes with MySQL is called that MyISAM. This is index sequential access method. This is an index. This is a special kind of an index that is provided by the storage system for making things faster. Okay, so unless you understand indexing, how the indexing is done, you will not be able to get to the deeper aspects of databases. Indexing is the most important part of the database systems, and this is often not taught at all in colleges. Okay, they don't really understand that indexing is core of the database system from a practical point of view. Okay, right? Now, if you look at these different kinds of indexing, that's what I'm going to teach you now in terms of what are the different kinds of indexing that will come into this system. For example, if you want to change the indexing system, this can be a very excellent project. If somebody is able to understand the indexing, I'm going to teach some indexing methods and how to change this indexing. Okay, then you can go into this code here. As you can see here, there's a .c code here. This more mi key. The keys are the basis for indexing. This is the indexing code. This .c program that actually does the indexing. And if you're able to change the indexing technique, you can go here, change this file with your new indexing method, and you can rebuild this entire MySQL and can experiment whether this is working very fast or not. Okay, that's the whole idea of actually providing this whole system for you, that you're able to not just learn the top level concept, but then you're able to go underneath the system. Okay, this is like you're not just a mechanic who is able to just make a little fiddle with the car, but you're an engineer. You know what exactly is the underneath technology that is used for running your application, full stack of the application. Okay, now before I go to the board and start doing this indexing technique, I also want to show you those 3 files that the MySQL generates for every database file. Okay, so if you come here, you can see this MySQL has the databases which I showed, including the RC November _ 18 _ 8, right? So if you go in here and look at in where lib, okay, there will be a MySQL here. This is the storage. This is the place where MySQL creates all the data files. All these different files are created by MySQL in this directory. For example, when you do a create table, okay, when you say create a database, this directory is created here. As you can see here, these are all the directories. Okay, I hope you are able to see the this thing. For example, we went into RC _ November. This is the directory, database directory. Okay, all the files for this database are in this here, as you can see here. You saw a table called users there. There are 3 files here, as you can see in this this thing. The green ones, okay, which I put there corresponding this thing. Okay, yes, that's one. The 3 green files there correspond to these 3 files that I'm showing there. Users FRM, users MYD, users MYI. Okay, that's the index file, and that is a data file. That is a schema file. If you change the program relating to the indexing, how the indexing is done, then you will get the different index here. Depending on what index scheme is being used, the corresponding thing will come here. Okay, so it's easy for you to now see. For example, if you just created an operating system data file, there will be only one DAT file. Whereas the MySQL database is creating for every table 3 files. One is a schema file, the other is the actual data file, the third one is the index file. Okay, I'm going to go deeper on this and show you how the indexing is done. Suddenly these are classes which are going to be a deep level classes, not something that, since we've come to the end, another 2-3 lectures only we are left with. I'm going to show you how the indexing is built by the database system, and for the students who would like to now do projects trying to have a different kind of indexing, they should be able to use whatever I'm showing here to see how the performance of these systems can be improved by looking at indexing as a basic thing that comes along with database systems. Okay, right. So let me just go to the board now and use this is where we are. We have just shown you how these three are, how these three files come in. We are going to now concentrate on the indexing, how the database generates the indexing. Okay. Now, given any table, I'm going to show you now each table and show you why indexing becomes very important. In the process, I'll also do the relational calculus, and we'll show you for each one of the relations how things can be improved. Okay. Right. Okay. So let me start with a simple case where what we see as a table. Okay, a table named table where we have the roll number, okay, and the student name and the CGPA. Okay. Right. So this is a simple table that we have in the relational model. This is basically A, B, C. Okay. In this, let us say A, this roll number is the key attribute. And what is the definition of a key attribute? Then is not going to be null, and then this is going to be uniquely defining this. Okay. Each of these records are uniquely defined, whatever number of records. Okay. As this number of records increase, if you have more number of records, this is where we are saying there is a select statement, which is the relational select statement. This is what the thing that we are doing. There is a condition, and then you are actually doing this. Okay, this is a relational, the select under this condition from this relation R. The SQL equivalent, this is a relational calculus, relational algebra statement. Okay, and if you are actually doing this, saying that there is a select from R, this is the all. There is no projection here from R under this condition where we have put this condition C here. Okay, where there is a condition C that we had put here. We said that where the user name is city. Okay, this is the condition that we had put here. Now this has to go into this table for this select statement to be executed. We are going into this table. Then we are saying one of the rows in this table has to be chosen based on that name that something is city. That's the relational algebra statement that we have. If you want to project also, for example, in this, under this condition, we want to project roll number. Okay. Then only roll number is what we are interested in under this condition. Then this is what you would have got. Okay. This is projection and this is selection. Okay. Now given this table, under this condition, select some rows. Okay. And then project based on these attributes here. Okay. Then the corresponding statement would have been select, for example, your ID from, this will be the projection, okay, from R where the user name is city. Okay, this is what you would have got. So this is projection plus selection. Okay, now if you do a join on two tables, okay, the other important operator that you do is take two relations and do a natural join on that. For example, if you take R and S and do a natural join under this R and S, so wherever there is attribute, for example, here there is A, B, C, and then here C, D, E. Okay, this join will make sure wherever there are common attributes, if the values agree, C agrees with C value here, then you are going to do the join of R and S. So you get the bigger table. Okay. okay, a semi-join would have projected this further, okay, on ABC. I'm little faster here, okay. I'm assuming that you have already looked at join, semi-join, all that stuff. So this is a join. If the join is under, this is a natural join where the common attributes have to be equal. If the common attributes are equal and you are joining the relations, that is actually a natural join. And further, if you are projecting it on the relation R, it's a semi-join. Okay, you are not creating the full table containing all the other stuff. A theta join would have actually got you with a condition here. If you put a condition, that what is the join condition? It can be any join condition. Okay, create a cross product of R and S, provide a condition here. This becomes a theta join. Okay, you can provide any kind of conditions here. A general cross product would have produced all the. Okay, this is a relational operator. Cross product will produce all the combinations of these tuples of R with S. That will be a general projection operator, okay, cross product operator. Now, from the cross product, you can get the natural join. This, if you actually select now only those where there is, for example, in this particular case, R dot A equals to S dot, R dot C, okay, only the C attribute is common, S dot C. This becomes the natural join, okay, right? This is equivalent to the natural join. R natural join S will be this, okay, right? These are equi-join, okay. You can also have any condition, then it becomes a theta join, okay. These are the operators, these are general. Then also you have, if there are other kinds of joins are possible, but right now we will not get into those parts. We understand that given two tables, two relations R and S, we can do a general cross product, we can do a natural join, we can do a theta join depending on the condition that we have, we can do the projection and we can do the selection, okay. These are the general operators that we can perform given a table R and a table S, okay. Now the question is, when you're doing these operators, you want them to actually work efficiently. You want them to actually go and then perform as fast as possible. For example, the whole idea of databases is, if you actually take the Aadhaar card database, the biggest problem in Aadhaar card database is when they're designing it, the efficiency. When people are searching for a particular data record, you don't want the system to be spending a lot of time trying to give you the information back. For example, if there are 120 crore records in the database, you don't want the system to take enormous time in terms of responding back to that query. Okay, that's the key problem in databases. As the number size increases, you don't want the system to be hogged down by these scalability issues. As the scale increases, it suddenly doesn't matter if you're talking about records of 100 records, 1000 records, they don't really create such a big problem, okay. If the book is very small book, thin book, okay, 10-page book, whether you have an index for the book or not doesn't matter, okay. You can go and then look at the book from end to end if you're searching for something. But as the book becomes 1 lakh pages, 2 lakh pages, 10 lakh pages, it's all alphabetically sorted, okay. Now you can go there and then hash based on that and the page can be obtained, okay, right. So that's basically called the hashing function, okay. What you're going to now look at it is, what are the different kinds of hashing techniques? Hashing techniques which can produce the equality searches or make the equality searches extremely fast, okay. That's what we're going to look at to start with. Okay, a simple technique for hashing is what we call as a static hashing. Okay, um, now given this, what we will see is what the static hashing does is, okay, given a what happened? Get some water. There, this one. Hash based on the username. Okay. Now, one way of hashing is, you know that a username starts with alphabetical thing. So to start with, we take the first letter, okay, of the name. For example, if the name starts with A, I know the page where all the names starting with A are there. So this is basically called the bucket. Okay. So now given all the A names, I know I have to go into this bucket. This maps to this bucket. This is hashes into this bucket. Okay. Right. Now when, let us say my bucket size here is n entries. Let us say to start with, I'll put it as 5. Bucket size is 5. Okay. Right. Now when I hash based on the name, based on the letter, I get into the bucket. Each bucket will store the values. For example, let us say in this particular case, if the first letter is A, let us say some AXX. This is one name, AXY, another name, like this. Okay. Similarly, if the name starts with B, there will be another bucket with 5 entries here. Okay. So for B, we have another bucket with 5 entries. Okay. This is basically called the static hashing. Okay. That means what you have now here is what is the ideal case? Ideal case is there is only one name starting with A, one name starting with B. Yes. One disadvantage here is that I not seeing the students. Okay. Yeah. So I'll be going at my pace, and then I will be. I know that this material is going to be a little deeper material. Okay. So you probably have to look at the recording again to get little better. Okay. Now the idea is, if I'm hand to hand, then you could have asked me questions and I could have given you some answers. Okay. So if any of you have questions, we can just go and then start having an interactive session. Do you want a 5-minute interactive session? Then I can actually pause here. Okay. Right. Anyone wanting to have a 5-minute interactive session? See, this shows how the hash index has to be built on the database. Okay. There are different kinds of hashing techniques. What we are seeing is a simple static hashing. Okay. Where given that there are bucket sizes, there are n of these buckets that are going to come from. Okay. Now the question is, if you look at the names, most of the names, practical names, may have to start with S, which means that this 5-entry bucket may not be sufficient, okay, for locating all the names with starting with S. This is like creating the index. This is exactly the same as creation of an index for the book. To start with, how we are creating the index for the book. You take all the names, create those page numbers. Now what's happening is, with a particular index, one page number is not sufficient. Then you have to store it in a different page. You have to give multiple page numbers there. Okay. Now go back to the back of the book. You can see, given a name, he gives all the pages where that name is actually found. Okay. Now that's the index. Now if for a particular name, if the numbers are more than 5, static one will make sure that you have only fixed number of slots here. If you exceed this fixed number of slots, you can't store them anymore in this buckets. Okay, so what they do is, there is basically the buckets. This is how the whole structure of storing will be. Okay, you will have the buckets and then the data. These are the data pages. Okay, these are the index pages. Okay, and then you are going to get what is called the overflow pages. For example, if with A, starting with name A, if there are more entries than 5, then you have to store it in the overflow pages. Then you will get an overflow page here. And there are buckets available here to say which is the data where this is stored. The data is always in the data pages. The book data is in the main book, but then the index, now you have a fixed number of index pages in the front of the book. If they are not able to hold the index, then you have to start storing the index at the end of the book. After all the data is stored, then these are called the overflow pages. Okay. Now in terms of your disk file, what you have is an index pages, data pages, and overflow pages. Okay. In the case of static index, if the buckets cannot hold the hash, the collisions and the more hash entries than the bucket can store, then it gets into the overflow region. Okay. Now imagine this. I'll give you the extreme cases now of arguments. Okay, when this hashing can work well and when this hashing can work, depending on what hash function you are using, how it is going to work. Let us imagine, for example, there is a case where all names only start with A, okay, and there is no other names, no name starting with B. This is an hypothetical case, and there are no names starting with C, any of the other letters. Only they are all names starting with A, with the first letter A. Then this hashing function will work very poorly. In fact, this hashing is useless. What will happen now? When you want to search for a name, what will you do? For example, there the username is city or something. Okay, there every name starts with some A. Okay, some A blah 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 stuff. So what will you do now for this name? You have to go into this bucket. This is where you can directly avoid searching to the entire records. Okay, starting from the beginning to the end. You don't want to search all the records. That's where you are using this hash function. This hash function will now map it into this bucket. Only 5 entries can be stored in this bucket. All the remaining entries are going to be in the overflow pages. So what will you do now? You come here, search here, and get into the overflow pages. And there is going to be a long overflow chain here. Okay, long overflow chain, which will sort of, okay, right? Now there are no more entries here. The overflow chain is the one which is very, very long. That's where static hashing has a weakness. If there are more entries getting added, okay, more entries getting inserted, and all of them are put into the overflow pages, there's a long overflow chain which will sort of hurt your. Okay, this is the first thing that you should realize. Okay, the second important thing why we are looking at hashing is good only for equality search. Okay, for example, here you're saying given a name you want to retrieve. This is an equality search. Given the name Janaki Ram, you want to go and then retrieve the record which is having that name. Okay. Now, if you want to get the records of all the students whose CGPA is greater than 9 or something, okay, then hashing doesn't really help, because now you need to go into the each record. You need to go into all the records and start getting the records which satisfy that condition. Okay, so this is one reason why databases don't use. Okay, the databases don't use hashing, mainly because they're dealing with range queries. They're not just dealing with hashing, okay? But then there actually changes into this hashing that people, if you're doing equality search, okay, in fact, even equi-join, when you're doing joins, okay, equi-joins, hashing is the best way to implement that operator, because all that you have to do is, given one table, you want to go into the other table and get the other record matching the value. Okay, you want to join two tables matching those values, right? So then also the equi-join, when you're doing the equi-join, hashing is a very good indexing technique. Okay, there are actually improvements on the hashing technique. Okay, now if you want to look at how the file, in fact, if you've seen the system that I've shown you, the storage system essentially is struggling to produce a good hashing for the database. For example, index sequential access method, that ISAM storage produces an efficient hashing technique for most of the operators, relational operators. That's the idea of that storage system. Okay. Now, InnoDB more or less takes the same kind of hashing techniques, but improves on the locking that happens on the records side. It actually does improvement on the transactional management system. And that's where you have different kinds of storage systems trying to struggle to come with a proper indexing technique. Okay. This can become very, very interesting, because as you start seeing, now where are databases going to, practical databases, where are they going to have problems? Before I go further on the indexing, I'll just take a few minutes to actually talk about what are the practical implications of using databases. Okay. For example, look at railway reservation system. Okay. Look at, for example, your system which is actually giving the results. Okay. Your 10th class results or 10+2 class results or any of the results. Okay. What happens at that point of time? The most important thing that happens to these databases is there is something called a flash crowd. A lot of people are trying to access the database at the same time. Okay. When a lot of people access the database at the same time, that's the time the database should be performing well. And normally that's the time the database crashes. Okay. For example, if you look at, most of us try accessing, for example, morning 8 o'clock, the railway reservation system, because there is some tatkal or something. That's the time we won't be able to access that database. Okay. More and more people trying to access the database, that is the time the database should be performing extremely well. Okay. That's the most critical thing for the database systems. And that's what you need to understand. Practical systems is not just about design. Practical systems is about performance. How well is your database system performing? Now that's the reason why all these indexing, storage techniques, how the locking is happening, all this becomes important. Okay. You were looking at my transaction management lectures the other day. Okay. Now you want to make a change to the table. Okay. Now is that whole table locked? For example, let us say you have a table here with 1 lakh entries. For a particular student, we are trying to change, let us say, his CGPA from 9 to 9.5. Okay. This is what is the change that we want to do. Now, do we lock a particular page and then make the change, or lock the entire book? What is the meaning of this? This means that only this transaction can have access to the book, which means the table is locked by the one who is trying to make a change to a single page. Okay. What says? It will go and lock only that page, 200 page. Okay. Take a book, for example. Okay. In the book, if two people are trying to access this book simultaneously, do you lock the individual pages they are accessing or the entire book? That means the book can be used only sequentially by different people. What says? The book can be used simultaneously by multiple people, but a single page cannot be used by two people at the same time. two people can write on two different pages at the same time, but they cannot write on the same page simultaneously, which is equivalent to saying that I do page level locking versus I do the book level locking. The entire table I lock versus I lock only a record. Okay, this will have enormous bearing on the transaction processing performance. If you lock the whole table, then it is going to suffer in terms of how fast this execution can happen, obviously. Okay, versus if you are able to provide concurrency at the level of pages where multiple people can write on different pages simultaneously, it is going to be much faster than locking the entire book at the same time. Okay. Similarly, if there is an indexing, proper indexing provided, then the retrievals are going to be extremely faster. The transactions are now not going to spend a lot of time searching the whole database, trying to find the relevant information. Now they're going to zip through. I ask for, please get me the record with the name where the username is city. It comes in microseconds if there is an index provided for me. Otherwise, it will start searching from one end to the other end. Then it's going to take a lot of time, 10 seconds, 20 seconds before this query can even get something. Then if I have to join with something else, I'm going to spend that much more time. So the database performance, which is extremely critical. For example, if you now start trying to book a railway reservation and it takes half an hour for you to be booking, no, it just goes off and the response comes only after half an hour, then you will be very frustrated with that database. As the scale of the database starts increasing, the end user cannot be made to wait because these transactions are working very poorly. They're actually very inefficiently implemented. So that's the reason why whatever we are now doing becomes extremely important for practical databases. Okay, a good indexing technique becomes very, very important when you are building your database. And hashing is one such index. Hashing is a very simple, easy index that is built, but it is good for equality search. Since it's good only for equality search, it is not good for other kinds of searches. Databases use much more complicated indexing techniques, which we're going to. ISAM is one index, and the other one is the B plus indexing, which we're going to see possibly in the next class. Okay, but what I'm going to do in today's class is I will sort of look at what are the other kinds of hashing, what are the improvements people can do on hashing to see if the hashing can become much faster or problems with hashing can be addressed when you're inserting or deleting the records. Okay. Okay, let me go into modifying this hashing index. This is a static indexing where you take the bucket sizes, fixed bucket sizes, right? When you're adding more than this fixed bucket size, the records are getting into the overflow pages. Okay. Now, if you want to actually improve upon this, you don't want to actually have more overflow pages. If there are more overflow pages, overflow chains, then the hashing is going to perform very poorly, because the long chains means that your searching is going to become poorer, because you have to search through all those long chains. Okay. Now, one of the ways in which this is modified is, there are two ways. One is called the directory searching. Okay, as this keeps growing, you want to actually have one more index on top of this index. Okay, so people have modified the hashing, and they call that as a directory hashing. Okay, and then linear hashing. There are two other variants of this hashing which people generally use. Okay. One is called the directory hashing, and the other is a linear hashing. Okay. Okay. What the static hashing is doing is, it's using a static hashing function. Okay. Right now, obviously, when for the first time I give you the names, this I'll use a simple example for you to explain. Okay. I know that I'm not using too many examples. I'm little faster also. There are only 4 or 5 lectures left now. I'm little faster. Okay. Right. But then let me slow down a little bit. Give you the hashing. At the end of the thing, I'll just explain hashing in a very simple way. Okay. Now let us say I have 3 names. Okay. Ramya. Okay. Sunad. Okay, and then Komal, okay, and then I have, let us say, Chaitanya to start with, okay. These are the names that I have to hash, okay. To start with, if I'm using static hashing, it's very easy for me to see that first letter, based on first letter, I can hash all these names appropriately, okay. All that I need to do is now just use only the first name, first letter, okay. Now, for example, this function, taking the first letter, you can say this map to some address here, which gives you the corresponding record here. Similarly, take the first letter here, the bucket size of 1 can actually take care of this, okay. First letter will make a distinction of all the records. So the key, the hashing can actually take only the first letter and can start doing this hashing, okay. Now there's no overflow chain, nothing. The bucket size of 1, every record can be retrieved now just in one order of 1 time, okay. Because I have only these 4 names, my simple hashing function of taking only the R's will be good enough, okay. To start with, people, when they are designing the static hashing, they will know all of this. So they will be able to come to start with a hashing function that is good. Now what happens if I have, let us say I start inserting now into this another name called Renuka, okay. Now this R also, if I take just R, it actually now maps into, you can start seeing that as I start inserting more and more with the same name, that overflow chain starts growing. As the overflow chain starts growing, when I want to retrieve a record with name Ramya, I don't know where in this chain it is going to be. So I need to go and search all these 3 records to retrieve the record starting with Ramya, Renuka, Revati. Okay, right? This is the problem with static hashing. What dynamic hashing does is, the minute it starts seeing this, okay, now start splitting this. This is not a good hash function, right? This is no longer a good hash function. Now just use the 2 letters, not just 1 letter, okay, right? To distinguish now, take 2 letters. Now the hash function will make a distinction based on the 2 letters. Now we have doubled. That means the chance of 2 people hitting at the same time is going to be less. Okay. What the dynamic hashing is, as you start entering more and more of these records, you start actually changing the hash function. Now you double it, triple it. For example, when you start seeing more, here you can see 2 REs have come. Okay. Now they are clashing, further clashing. Take the third, 3, all the 3 letters, not just 2 letters. You keep increasing now. As things are actually clashing, start clashing, you start actually taking a different hash function. Every time you double the hash space. Okay. Now instead of, if you are taking the hash function based on the first letter, it is going to be some fixed number of letters, right? Now take the first 2 letter combinations, the hash space increases now, okay? Then you take 3 letters if required, 4 letters you require. That's what basically the idea here, okay? Now, when you want to dynamically change the hash function that is being used, what you do is now, don't change the hash itself, the buckets itself, but then create a directory. That means an index on top of this, okay? And that's what exactly is changed, okay? Now you come up to start with, this is the hash that you have. For this, now you build a directory for this, Okay. Now the first level directory says that all A, B starting letters will come here. Okay. D, E, F. This is the directory. Okay. This will now point out to the buckets that you have here. Okay. Whatever buckets you have. Now when you see that this is no longer a good hash function, you want to change the directory, then rework out this directory to say that it will have now lot more entries. For example, you will have AA, AB, AC, all this. Now this is split into much bigger hash function. Okay. Now the initial hash function is this. Now the modified hash function is this. Okay. Now you will be using this modified hash function. You are increasing the space. Since you are increasing the space, you will not get into the overflow chains. That is the idea. Now earlier, first place you used only R. The second time when you started inserting, you started using the 2 letters. Then you can use 3 letters. Then you can use 4 letters. So for each one of this, the directory structure is going to change. For example, once you modify the hash function, initial hash function is using only 1 letter. The second hash function is using 2 letters. So the directory is changed here. Everything is reworked out based on the directory. This is not touched, but this side it is touched. More buckets are created. Okay, right? What linear hashing does, okay, we'll not go into depth of linear hashing. What linear hashing does is, it doesn't actually, once you're changing this hash function to double, it will double it linearly. That means it doesn't actually initially to start with, the directory would have doubled the entire hash space. The number of buckets would have been doubled in the first place itself. Whereas what linear hashing does is, linear hashing slowly as you start inserting, it actually progressively doubles the space. Okay, that's what basically we mean by a linear hashing. Okay, it's more or less does the same thing. To give you some idea of this, for example, when you are trying to insert now here Revati, okay, what directory function would have done is, this would have taken and would have actually created this entire space. The minute you're actually clashing and this needs to be split, this hash function needs to be changed, it creates the full directory structure. Okay. Whereas in the case of linear hashing, what it does is, the first bucket that is available here, for example, here let us say Ramya is the first bucket. Only this bucket will be split. Okay. This bucket will be split with taking 2 letters. Okay. That means only this is split to start with, and then next time you are inserting something, the next bucket is split with the 2 letters. Like that, it will progressively start splitting, which means that it is possible that there are going to be some overflow chains, but then it limits the growth of this overflow chains, because by the end of the round, everything would have been split. Okay, by end of some insertions, all the buckets would have been split, whereas directory would have ensured the split has happened much earlier. Okay, right? So it's a question of how the hash functions are changed. Okay, progressively how the hash functions are changed. When you start seeing that the overflow chains are growing, how dynamic hashing, to start with static hashing would not have handled this problem. Okay, whereas the directory hashing will split the hash function to the new hash function. When you have a new hash function, it splits everything in the beginning itself. Linear hashing progressively splits everything, but at the end of some point, you know that it has actually split. For example, all the entries would have been split into 2 progressively. Okay, right? By some point, all these would have been split and would have come to this point. Okay, but not done at one go. As far as linear hashing is concerned, it progressively splits. Okay, now once you progressively split, again it's possible the directory hashing would have split it into 3 at one go. But whereas linear hashing will again start doing it 3 letters at progressive way. So linear hashing does things in a progressive way, whereas directory hashing would have split it completely at one go. Okay, right? This we'll give you some examples in the next class, but then the most important thing that you should realize here is the hashing is useful only for the equality search. Okay, when you are trying to retrieve a record which matches given a attribute name, given the equality on that attribute, you can go and then retrieve the record in a fast way when the hashing is available. Okay, right? What we are going to do in the next, generally databases don't use a simple hashing technique like this. What they use is what we saw as a B plus indexing. Okay, there's a different kind of an indexing they use, which is good for both range searches as well as equality search. B plus does almost the same way. This is the best for equality search. Hashing is the best for equality search. But B plus also does equally good. Not as good as hashing, but then it does equally good. Okay. Why is this becoming extremely important? Now imagine, I'll also motivate you by giving, all of you are using now the Google Maps, right? Most of you will be using on your phone nowadays Google Maps. Okay. If you look at Google Maps, it is also doing some kind of searching. Okay, searching and indexing and searching large data sets is what it is also doing in some sense. Given a name, given a something like Lakeview Road in IIT campus, if you give that and ask it to search, it has to go and then search in the database where that exists. Okay. Now it's most of the time image databases require not just one level of indexing. This is a spatial search. If you look at X and Y coordinates are available and you're actually doing a spatial search. Okay. Now that becomes an interesting problem. When you want to locate some place based on the X coordinate and the Y coordinate, the indexing cannot be one dimensional. Based on X you are searching, it becomes one dimensional. Based on Y you are searching, it becomes one dimensional. But if you want to search some place based on both X coordinate and the Y coordinate, it becomes multi-dimensional search, multi-dimensional indexing. Here we are talking about only one-dimensional index. Given one index, okay, now there is an attribute and there is a name. Based on that, we are actually indexing. This is a single-dimensional index. But generally, databases often need to create multi-dimensional index. For example, if you look at the spatial databases and you want to search into the spatial databases, you require a multi-dimensional index, not just a single-dimensional index. In the next class, we're going to look at the B plus indexing, okay, and also take a simple example and show you how this index is built by the database and how they use it for optimization. When the select queries are being fired, how it makes them efficient. Okay, we'll stop here and come back. I think I'm going to come only for 2 more classes. What I'm doing is both the SQL and the transaction processing, the lectures are already available. I'm told that is actually being sent to you. Okay, so I'm not actually covering that. What I'm covering is those which doesn't exist. For example, these parts which are deeper parts doesn't exist there. So those are the 3 lectures. The next 2 lectures also will cover. One of those lectures will cover indexing. The other one will cover special kinds of databases. For example, there is video databases now. There are image databases. There are all kinds of databases. Okay. Now, how do we store and then retrieve data from those databases is completely different from the traditional databases. Okay. That's what we're going to do in the last 1 or 2 classes. Those are the things that we're going to do as part of the course. Okay. We'll stop here and come back on probably on Wednesday. Okay. Right. Yeah. Okay. Thank you.